Hi everyone, welcome back. Welcome to Sir Ranran's math tutorial. We have a new episode of tutorial today. A new lesson, just a very short lesson that is to be discussed today. And before we discuss, I'd like to say thank you so much muna to the following who subscribe our channel, the Kaguro Vlog Official, the Kaguro, yeah, that's Kaguro Vlog Official of my friend. And then the following also who subscribed recently, Julian Westro, Elrea Cutie, AK Vasquez. Thank you so much for subscribing. For you who did not subscribe yet, subscribe now. I'll shout out your names in here the next video that I'm going to make. All right. So let us not waste time. If we are ready, are you ready? If we are ready, now we are going to go on. So let me welcome you to the lesson measures of position for group data. Measures of position for group data. In the previous video that I posted, we talk about measures of position, but that's ungroup data. This time it's group data. So what are the measures? Okay, that we'll be talking here, the same. No, the measures are the quartiles, deciles, and percentiles. So we'll try to learn solving, calculating those when it's already a group data. Let's try to find out what are we going to do. Okay, here the formula for the percentile, decile, and quartile of group data are similar to the formula for the median of group data. I think you can recall during your lessons in the central tendency, measures of central tendency, you're computing for median for a group data. So it's just similar actually. The formulas here are just similar to that formula. Now, for quartile, we have here Q sub k is equal to B sub L plus the quantity of Kn over 4 minus Cf sub B over F sub C times I. Okay, that's yeah. Okay, that's the quartile. And for the decile, what is the formula? The decile is D sub k is equal to B sub L plus the quantity of Kn over 10 minus Cf sub b over Fc times I. What changes is that the denominator only. Okay, the denominator here in the quartiles 4 and then in the decimals 10. And what about the percentile? Pk or P sub k is equal to B sub L plus the quantity Kn over 100 minus Cf sub b over all over F sub C times I. As you see, it's 100 here is the denominator. Just remember, quartile is, it divides the, you know, score points that divides these are score points that divides the data into 4 equally. And these are score points where it divides the data into 10 equal parts. And then percentile, it these are score points that divides the data into 100 equal parts. And so you see it just changes 4, 10, 100. You know what, guys, I'd like you to look into muna the formulas na. This terms here, I mean these expressions here that are included in these equations or formula, these are actually called locators, the ones with the denominator kn over 4, kn over 10, kn over 100. These are locators here, okay? So it will help you actually locate where the quartile is, where the decile is, where the percentile is. In this case, group data, so it would be where the quartile class, decile class, and percentile class is. Where n here is the number of observations or total frequency, and I is the class size, and then B sub L is the lower boundary of the class that contains Q sub k, D sub k, or P sub k. And then the CF sub B refers to the cumulative frequency of the lower class that which precedes the class containing Q sub k, D sub k, or P sub k. And finally, we have F sub C, the frequency of the class where Q sub k, D sub k, or P sub k is located. Now, let's try to learn by doing a problem solving. Here is the problem. Given this group data, it's already presented using a table, huh? In the to find the upper quartile of the employee's annual salary in the company. Okay, according to the problem, this data here is a data of the employees pertaining to their annual salaries and is presented in class intervals. The first column here are the annual salary presented in class intervals, and the second column their annual salary based on class boundaries, and the third column are the number of employees, and the fourth column are, the cumulative frequency. Okay, the cumulative frequency. Let's take it one by one. Here, as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 classes here. We call it classes. These class intervals are called classes. Okay, so these classes, we have the left and the right, um, boundaries. In the left, these are the lower limits, and then the right, the upper limits, no, or the lower boundaries, the upper boundaries. Now, you can have that, second column from that limits here. How we got this annual salary based on class boundaries now? Here in the left column, you notice that there's that zero point 0.5, and also in the right, in the right, there's also zero point 0.5. How was that, how we arrive at that numbers? Look at here example. You can see that the class interval is from 100,001 to 200. Okay, 100,001 to 200. The 100,001 is the lower boundary, and then yeah, we can get the limit of that one. We subtract zero point 0.5. All these ones here subtract zero point 0.5, and in the right you add zero point 0.5, and that you can get the boundaries. You can write the boundaries. Okay. So that's how we get it. And the number of employees here, the frequency. Okay, the frequency. That means the tallying is done already, and it's already in numerical form. 10, 18 belongs to this class interval, 15, and then 20, 10, 8, 5, 3, 1. Okay, these are the frequencies. And there's only one employee that is under here in this class interval. Might be na this is the employee that has the highest no, salary. Okay, annual salary. In that, okay, what about the cumulative frequency? How we get this? Okay, it's very easy, no? You look at the frequency, you're just going to copy the first. Okay, copy the first, then add the next, the next number. Okay, 10 plus 18, that is 28. Do it again until you were able to have it completely added. All right, 10 plus 18, 28, 28 plus 15, 43, 43 plus 20, 63, 63 plus 10, 73, 73 plus 8, 81, 81 plus 5, 86, 86 plus 3, 89, 89 plus 1, 90. This 90 actually refers to your total number of employees. Okay, it's equal to the sum of the frequency here. If you are going to add the frequency here, that is 90, meaning the 90 is our n, the number of employees, and in this case in the data it's the total number of observations. Okay, so right, take note, our n would be 90. If we are going to use the formula, it's 90. Okay, now how to solve that problem? We are to solve the upper quartile, or shall we say quartile 3. The formula is Q sub k is equal to B sub L plus the quantity Kn over 4 minus Cf sub B over F sub C times I, where I is the interval. By the way, what is interval here? What is the interval? How can we get the interval, or where we can get it? Here, look at the class intervals here. If you're going to look into each of the interval, they have constant interval or class size, right? So if you can see, 100,001 to 200, the interval is 100,000. It follows the same. Okay, it follows the same. So your I in this set of data, in this group data, is 100,000. Okay, 100,000 is your I. So you have values already. Your N is 90, your I is 100,000. Okay, Now, first, we determine the class where Q3 belongs. Okay, how to determine what to do? Okay, in the formula, you see a kn over 4. Actually, this is our locator, as I told you, locator, meaning this will guide us check where is the Q3 belongs, the class interval, referring to class interval. So hahanapin, we will look for the class interval where Q sub 3 belongs, and that we will use the locator. So we will solve it. For Q3 locator, you have Kn over 4 or 3n over 4. Why 3n? We're talking about quartile 3. So we will substitute 3 to k. Okay? And that becomes 3n over 4. Remember that our n is 90, as I told you, 90 because that's a total number of employees or total number of data that we had, observations that we have in our data. So you have 3 times 90 divided by 4, and that you will have a result 67.5. That means our locator is the 67.5. So the position of quartile 3 must be in the 67.5th position. Okay? So we will try to check that. Here it's already given in the solution. The class interval where we can see that 67.5 position is at the 500,001 to 600,000 interval. Okay? That's where the 64th to 73, this must be 64 to 73rd salaries are found. Okay? This is where 67.5th salary or the quartile 3 is found. You check here. I want you to check here. Our 67.5, oh, it's not 64, it should be 63, is located somewhere here between 63 to 73. So you're going to use the cumulative frequency as to locate it. Meaning after you can get the answer here, you look into the cumulative frequency where you can see that, but it's not found here. 67.5 is not here exactly, no? But you can, yeah, remember that 67.5 is located between 63 and 73. Okay, 63 and 73. And 67.5 is close to 73. So let's go up. Okay, let's go up. Now, that locates our class interval where Q sub 3 is found. Where Q sub 3 is found. Thus, it says there 500,001 to 600,000 interval is the quartile 3 class interval. And that you can identify its lower boundary because it's important. It's needed in the formula B sub L, right? B sub L is the lower boundary. That's 500,000.50 because we always subtract here 0.50 to get the lower boundary. Okay, to get the lower boundary, we always subtract 50 because the upper we will add 0.50. Here, subtract 0.50. Yon. Okay, so that's why we have here 500,000.50 is our lower boundary. So our frequency for that class interval is 10. That's needed. That's our F sub C, the frequency of the class interval Q sub 3. Okay, and then what is the 63? Remember, we have in the formula CF sub B, the cumulative frequency of the class before. That's the class before, or the class that precedes the Q3 class interval. So before, to make it easier, before the class where Q3 is located. So where is the class before? It's here. It's the 400,001 to 500,000 class interval. Okay, and that is the cumulative frequency 63. Now, complete information data that we need to solve using the formula is now complete. We will now continue. So, going back to the formula, you can now say that your BL or B sub L is 500,000.50 plus course, your kn over 4 is already been solved. That is 67.5. And then this minus 63 is our cumulative frequency of the class before, okay? Or that that precedes the class where Q3 found. Yun. As I told you, it's here, 63. And that over 10. Why 10? Because the frequency of the class where this class belong is 10. Okay. Then, what is this? Is our I. I told you that our I is 100,000. Where we base that again? I is based here, constant, the class size. We say interval. Okay, what is the interval between 100,001 to 200? Obviously, is 100,000. Okay, it goes the same in all class intervals here. So that's why we have 100,000. Now, all you need is simplify. Copy first, 500,000 0.50 plus, you simplify this one, that's a 4.5, then over 10 times 100,000. And there you have 500,000.50 plus, as you multiply that, then divide by 10, of course, you will arrive at a 45,000. All right, 45,000. And that when you add, finally, you will have a final answer, 545,000.50. That's your Q sub 3 value this time. Okay, that's your Q sub 3 value. If you're asked now, oh, what is the upper quartile of the salaries of the employees? That's your answer is, oh, it's in the 545,000.50. Okay, that's your answer. All right, let's continue. I hope that's understood. Let's proceed to another problem. Example 2. What percent of the company employees have annual salaries lower than 500,000 pesos? That's Philippine money. Okay, that's a Philippine money. What percent of the company employees have annual salaries lower than 500 pesos? So we will refer to the data in the example 1. Here's the data here. I'm going to show that one to you again. Solution here, as you check, this means that the P sub k, or the percentile that you are asked, okay, it's what percent, meaning you are asked with percentile rank. Okay, what percentile rank? That is the question, since you are asked what percent. Okay, this means that the P sub k is equal to 500,000 as to the given. Okay, and we need to solve for k. We need to look for the percentile rank. This must be a small letter k. Okay, this salary is in the 400,001 to 500,000 class interval. Okay, why? Okay, you cannot use the locator actually, guys, because you are asked for the k, no? So you cannot use that, but you can use the value. The value that is 500,000, where what is asked is the rank lang man, the percentile rank. So you have the value already of the percentile 500,000. So let's check where we can see that 500,000. It's actually here in this class interval. 500,000 is here. So from the class interval 400,001 to 500,000, that is where the 500,000 belongs. So we will then consider this one as our percentile na our problem in the yeah, we're looking the problem that we've been looking for as to, you know, the class interval being given with the value 500,000. So this is our class interval. Take note for that. And so what we are going to do, the class boundary can also be identified now. That's a 400,000.50. Okay, let's go back to the data. Your class boundary is here, 400,000.50. Why? Because our class interval is here. You just subtract 0.50 in this number, okay? 400,001 minus 0.50, you will arrive at 400,000.50. That's your lower boundary, or L sub B. Now, what else do you need to see? So the frequency, what is the frequency? 20. The CF sub B, 43. Look into the data. Okay, this is the interval. This is the interval, the class interval. So the frequency, its frequency is here, 20. All right, 20. And take note, the cumulative frequency before that is needed. Okay, is needed. It's before this class. Okay, you are going to consider use the cumulative frequency of the class before the class here. Okay, so we have the cumulative frequency of the class before the class here that we choose. That's 43. Now we have now complete data, 43 as CF sub B, 20 as our F sub C, and our lower boundary is 400,000.50. Our class interval the same. Our I is the same. Our I is 100,000. Okay, our I is 100,000. So we are now ready to solve for K, the percentile rank, not the percentile value because the value is given 500 pesos. Okay, now we will use the formula. P sub k is equal to B sub L plus the quantity of Kn over 100 minus Cf sub B over F sub C times the I. You know everything already here. All right. So the value is already given, P sub k. That's a 500,000. So you will substitute that here. Okay? And then the boundary, the lower boundary is given already. You can check it already. You can copy that. That's 400,000.50 plus the quantity of k times 90. Why is it that k is not being replaced yet by a number? Because this is the problem. This is what is asked, the percentile rank, what percent. Okay, so no value yet for that k. That's why we just copy k times 90, where 90 is our n, the number of employees, over 100, because that's in the formula. That's for the percentile, right? Minus 43, and you know the 43 is our cumulative frequency before the class before, right? You know that. And then all over 20, since our frequency, as you can see, is 20. Now, going back, times 100, because our I, class size or interval, is 100,000. Okay, we will now simplify it. This one, if you are going to transpose it, right? If you are going to bring that to the other side, that will become a minus. So 500,000 minus 400,000.50 now turns to 99,999.50. Okay, as you subtract that. Now, you simplify also here. Actually, this k 90 over 100 is the same as 0.90k. Okay, if you divide k 90 over 100, it's the same as 0.90k minus 43. We just copy that. We just copy times 5,000. Why 5,000? Actually, you can do the cancellation of 20 and 100,000, right? You can divide, do cancellation. It's 500,000. I mean 5,000. Then what's next? Of course, this is expression with a variable k. You can distribute that. You can distribute. So 5,000 times 0.90k is 4,500k. And then you have to subtract 500 times 43, that's 215. Okay, you see that? You just simply distribute the 5,000 to 0.90k and negative 43. Then you can have 4,500k minus 215,000. Then you simplify further. If you are going to bring this the other side so that you can isolate k, okay, you can isolate this term here, 4,500k, so you can solve for k later on. You can bring 215 the other side and it will become a plus, right? If you add that to 99,999.50 plus the 215,000, that will become 314,999.50, and that is now equal to 4,500k, right? It remains 4,500k. And then what's next? You are going to divide it by 4,500. Divide also the other side by 4,500, and that you will have an answer for k, which is 69.99, or approximately 70. So you can see that 70, you can say now that 70 is your value of your k. Therefore, the 500,000 pesos is at the 70th percentile rank. So you were able to answer the question, what percent? It's the 70th percentile rank. Okay, and that value is 500,000. So what is the 70th percentile rank of 500,000 of the given number amount? That's 70th. Okay, I hope that you do understand that one. Now let's proceed to the problem that I want you to work with. Okay, problem for practice. Just refer to the data, the same table, and then I want you to determine the eighth decimal. I mean, sorry, the decile. This is decile of the employee's annual salary in the company. So decile, you are to compute the decile 8. Okay, the decile 8. You can use the formula above for decile. You use the same process. Use the locator, locate it using the cumulative frequency, and then identify the class interval. And so you can have the class boundary, the frequency, and the cumulative frequency. Then substitute the formula. Then you will arrive at the answer, the correct answer, if done correctly. I want you to comment your answer at the comment section. Thank you so much, guys, for watching, and thank you also to my students who keep on watching my videos. Bye bye.